Hi folks, we're going to continue our work on variables today. So let's just do a quick recap of where we're at. So we know that a variable can be used to represent a number we don't know yet, or something that can take on multiple values. So in particular, let's say I'm looking at just a side length, could call that x, and this could represent any side length. So x could be 2 centimeters, x could be 10 centimeters. All right. Now, another thing we can do is we can maybe operate on these here. So for example, if I take this side length x and then I multiply it by another side length x, we know that that's going to give us the area of a square. So x squared, when we multiply x times x, could be useful to us. Okay. We also know that we can add these expressions because let's say I've got exactly 2 of these squares. So here, another x, the area is x squared. So if I want to represent the area of both of them, I can add these two together. And I've got 2 of these x squareds. So 2 times x squared. Okay, so what we see we can do is we can work with these variables. Okay, we can multiply them with each other, and we can also multiply them by numbers, and that allows us to even add them. So here, if I've got 2 terms that are the same, what we call like terms, in other words, they have the same variable and the same exponent, we saw that we can add them together, and we add them by just adding the number that comes in front, the number that multiplies. So here you have 1x squared plus one other x squared. You have 2 of these x squareds. Okay, now don't forget that these numbers here that multiply the variables are called coefficients. Now, there's nothing that says that we can't multiply 2 different variables. So as an example, let's say I've got a rectangle where the length is equal to x and the width is equal to y, then the area would be given by x times y. And again, I could have 2 of these rectangles. So I can have the total area being 2xy, and so on and so forth. All right? So these expressions that involve the product of variables, numbers, and exponents or powers of variables are what we call terms. Okay? And we can bring together multiple terms, and this is where now we're going to define some new terminology. The catch-all phrase for these things are called polynomials. Now, poly is the word for many, nomials for numbers, so you got many of these things. So here we have that a product of numbers and variables, what called a term, is also called a monomial. Okay, so here if you look at the example, 4x squared is a single term, hence it's a monomial. And of course the coefficient, here the number that multiplies the variables, is the coefficient. But then of course you could have more than one term. You could have a sum or difference of 2 monomials. This is called a binomial. So here, this here would be a binomial because it's a sum or difference of 2 terms. And then 3 terms, trinomial, like this one here. Okay? But in general, we use the term polynomial for any sum or difference of monomials or terms. Okay? So notice I'll use the word term and monomial interchangeably. Okay? So it could be just one single term, it could be 20 terms. These are all considered polynomials. All right. Now, one other term that I'll bring up is, say you've got an expression like x cubed minus 2x plus 3. Okay, if you take a look at that last term, just 3 on its own, you might say, hey, wait a minute, 3 on its own, there's no variable. I'm not multiplying by a variable. Well, you can think of it as multiplying it by a variable. Okay, so x cubed minus 2x plus, now what power of a variable gives you something that won't change the 3? In other words, is there something that gives you 1 as a result? Well, you can think of this as 3x to the 0. But of course, we saw that any number to the power of 0 is just equal to 1. So we don't bother writing because it's doing 3 times 1. And don't forget here that when I have x on its own, it actually does have a power. It's power 1. but we just choose not to write it because x multiplied by itself just one time just gives you x. Okay, so we're going to start using this terminology here when we refer to uh, multiple terms. All right, so first thing I want you to work on is I want you to think about this idea of adding or subtracting polynomials. So if you look at these two examples, I have this polynomial, I'm adding that polynomial, and in the second one, I'm subtracting these two polynomials. So using what we worked on the other day on adding and subtracting like terms, okay, I want you to figure out how you would go about adding these two polynomials. This one here should be fairly straightforward, but this is the one that I want you to think about it. Because remember, this subtraction here, you're subtracting everything in that bracket. So I want you to think about how you're going to deal with that, and then see if you can come up with a rule for dealing with subtractions of polynomials. All right, so we'll give you about 3-4 minutes to figure that out, and then we'll come back and take it up. All right, so let's take a look at these here. So when I look at this first polynomial, I mean, it happens to be in brackets. So of course we need to try to simplify what's in brackets first, but I look at this expression here, nothing simplifies, so this won't change, 2x squared plus 5x minus 4. And now I'm adding everything in this bracket here, and I see again, nothing can simplify. Okay, so I'm just going to add all these terms to the initial ones I started with here. And now I can treat this like we did before. I have a whole bunch of terms that are being added and subtracted. And what we saw is as long as you keep the sign in front of the number, they can be done in any order. And in particular, I'm going to do them in the order that allows me to combine like terms. So I look around here. Now, I may or may not have mentioned that when we give an answer like this here, we'd like the highest power of x. If there's only one variable, we'd like the highest power first. So I look here and I see, there's only one power of 3. So that one is not going to change at all. So I'll keep that first, and then I'll look for any squared terms. And I see that there's a squared term here and a squared term there. So notice again how I always carry the sign that comes before the number as part of my term. So now let's bring these together, and I see that I have 2x squared minus 3x squared. So 2 minus 3 is -1. So I'm just left with minus x squared. Again, as usual, we don't write a coefficient if it's 1. All right, so now I see that there's these two x terms. Okay, and so here I have 5x minus 1x. I'm left with 4x. It's positive, so plus. And then lastly, we have -4 plus 7. So -4 plus 7 is 3. So I'm left with plus 3. And this is as simple as I can get. Okay, so pretty straightforward with addition. This one here now, let's come to this one here. So I look at this first expression again. There's nothing I can simplify in the bracket itself, so I'm just left with whatever was there previously. Okay, now this is where we have to be careful, because I'm not just subtracting the 2x squared, I'm subtracting everything in this bracket. Okay, so I'm subtracting the 2x squared, but I'm also subtracting the 6x. So when I subtract a positive value, it becomes, again, subtraction, so minus 6x. And now here I'm subtracting a negative number. Of course, we know that when we subtract a negative number, that becomes an addition. So that becomes +1. Okay, so you can maybe draw these little arrows as a reminder that you have to subtract everything in the bracket and change the operation as necessary. Okay, now I can go ahead and simplify. So I've got my 6x squared minus 2x squared, so 4x squared. Then I've got my 3x minus 6x minus 3x. And then finally I've got my -5 plus 1 leaves me negative 4. Okay, and this is as far as I can go to simplify. All right, so now what we want to do is see if we can come up with a general rule. Well, regardless of what was in this bracket, I would be subtracting each term. So we realize that this plus 2x squared, when I'm subtracting it, becomes minus 2x squared. Here, this plus 6x, when I'm subtracting it, becomes minus 6x. And here, this minus 1, when I subtract that negative number, becomes plus 1. So I can reason out that when I'm subtracting a polynomial, it's going to change the sign of each of the terms inside the brackets. Okay, so here we can say it will change the sign of each term in the bracket. And then from there, I can continue on and simplify. All right? So let's put this together. Let's take a look at the notes. So first of all, this is something we had seen earlier. You can add and subtract polynomials by doing what? By combining like terms only. So here I was only able to combine the squared terms and the x terms. All right. Now the order does not matter. Just make sure that you use the operation that comes before the next term. So here, when we do 2x squared, we have to subtract 5x squared. Always use the operation that comes before the term. Okay, and when you're subtracting, the sign of each term in the second polynomial will change. So here we see we're subtracting all of 2x minus 1. So it means we're subtracting 2x, and then we're subtracting negative 1, so that becomes plus 1. Okay, you'll get some practice on this later on. So now I want you to go to this next question here. I want you to remember, essentially we've done this before because we've combined these terms already using our exponent rules. So I want you to go through these and just remind yourselves how you would use the exponent rules to simplify these expressions. So we'll give you about 3-4 minutes to do that. All right, so let's have a look at these. So this one here, pretty straightforward. We've already referenced it. So x times x, you can think of this as x to the 1 times x to the 1. And of course, we know that when we multiply two powers with the same base, we add the exponents. The base does not change. Here, similarly, two powers with the same base, we can add the exponents, so x to the 6. Now here, we're multiplying two terms. Now remember, multiplication can happen in any order. 3 times 5 is the same as 5 times 3. So here what we're going to do is we're going to rearrange them so that we're multiplying expressions we can multiply together. And what can we multiply? Where we can multiply numbers. So 4 times 3, of course, is 12. And we know that we can multiply powers with the same base. So we've got x cubed times x, which is x to the 1. So that's x to the 4. And we see here how we can fairly easily simplify these expressions. All right? So now let's take a look at this here. And now we see that, look at that numerator, and there's nothing that we can simplify. Okay, we can't bring together the x to the 5th and the y squared, or same thing here in the denominator. But like as before, we divide those terms that we can divide. So here you can divide 4 and 14. Now again, because this is not the nicest of fractions, what we can do is we can simplify it. So take a look at these two numbers. What factor do they have in common? Well, I can divide 4 by 2, and I could divide 14 by 2, and I'm left with 7. Okay, let's take a look here. You have x to the 5 divided by x squared. You're dividing two powers at the same base, you can subtract them. So I've got this 2 left in the numerator. Here now, x to the 5 divided by x squared is going to be x cubed. And here we've got, let's see, think about what would happen there. Okay, I've got y squared divided by y squared. 2 minus 2 is 0. So y to the 0. And then, of course, in the denominator, what's the only thing we have left? We have that 7 left. Okay? And this is not an incorrect answer, but this is not how we're going to leave our answer. Because, of course, we know that y to the 0, anything to the power of 0, is equal to 1. And we're not going to write that down. So our final answer would be 2x cubed divided by 7. And so we've got it much simpler. Okay? So let's take a look at this rule here. We see that we can multiply and divide monomials. So notice here we're just talking about polynomials with one term. We can multiply and divide monomials by multiplying or dividing the coefficients, like we did here, like we did there, and then multiply and divide the powers with common bases using our exponent laws. And you have a couple of examples here that you can follow. Okay? So last thing I want you to look at here is how we can take the power of a monomial. Okay, and again, this is something we have seen before when we were studying the exponent rules. So I want you to think about how you would simplify these expressions where you have a monomial as your base in the bracket taken to the exponent up there. Okay, so take maybe 2-3 minutes to solve those. All right, so let's take these up here. Now, the trick here is that this exponent 3 applies to everything in this bracket, okay? And one of the things that people sometimes forget is to apply it to the coefficient, to the numerical value. They just think, oh, let me use those exponent laws, but it also applies to the 2. And here this applies to the -2. So I'll write out all the steps the first time, but the second time, you're going to see that I'm going to try to skip the step that I'm going to write now. So here, the exponent 3 applies to the coefficient 2. It applies to the x to the 4. It applies to the y to the 5. And it applies to the z. Okay, so now simplify this. 2 times 2 times 2 is 8. Here we know that power of a power, we multiply the exponents, so that's going to be x to the 12. Here we multiply y to the 15, and then finally z to the 3, since the exponent there is 1. Now I'm going to do this second one, but without writing this step out, okay? So the first thing it's going to apply to, and this is very important, is it applies to the -2, okay? So think about what's going on. -2 times -2 is +4, times -2 is -8, and then the -8 times -2 gives me +16. Okay, when I multiply a negative number 4 times or 2 times or 6 times, the end result is going to be a positive. Whereas if I multiply it an odd number of times, it will remain negative. So now I'm going to do a to the 6 to the power 4. So I multiply the 6 and 4, so a to the 24. And then finally b to the 5 to the power 4. So 5 times 4 is 20. So once you stop making any errors by writing it out fully, then you can start to skip that step of writing the individual powers and solving it all in one step. Okay? So just as a reminder here, a monomial, so again, we're talking about something with just one term to an exponent, can be simplified by applying the exponent to the coefficient, meaning to the numerical value, and then to all of the powers, again, using the exponent rules. Okay, so you're going to practice some additions and subtractions of polynomials in a little bit. You're also going to be practicing multiplications and divisions of monomials. You'll get sheets for that. But I want you to copy down these examples to practice powers of monomials. And you see in these here, not only are you doing powers, but also multiplications and divisions. All right, so be sure to copy this down and then work uh, on the exercises.